I'm Logan Westhoff, and I'm here with Tristan Stevens. We wrote this code together. This is Lab 3, Memory and Variables. First, we're going to define a variable called count, and we're going to store it in memory address 75, right, 75 right here. Boom. So that's going to be our count now. We're going to load the number 800 into our H and X registers, and we're going to store that into 76. So 76 right here, and since it's 16 bits, it's going to spill over into the next one. So right now this is the H register, this is the X register, but we're going to be reassigning those pretty soon. We're going to load 77 into the accumulator, and then we're going to add 1 to it, and then we're going to store it back in there. So boom, we just did 16-digit math, or 16-bit math, because we use 2 cells to do it. Part 2, we're going to move number 1 into our count variable right here. So our count is now 1. We're going to clear the H and X registers. We're going to load the X register into memory location hex 60 right there. So that's going to be our X register location. And we're going to move 248 into 71 to initialize our counter for a loop. So that should be right here. Excuse me, right here, 71. We're going to move count, which right now is 1, into our X location, which is 60. Boom. And then we're going to load count, and then right here, we're going to add 1 to it, and then we're going to store it. Boom, there it is. We're going to load number 71 into the accumulator, which is right here. Boom, this is our counter. So we're going to add 1 to it, and we're going to store it. Boop, right there. And as soon as that reaches past FF, we're going to break the loop with this BCC coming into here. So each time we're going to move count into where the X is, should be right here now. Boom. We're going to add 1 to count, and then we're going to up our loop counter, and then we're going to restart until this overflows. So it should go through 8 times. 4, 5, 6, 7, 8. Then we're going to move on to the next section. Next section, we're going to move 1. We're going to restart our count. We're going to clear our H and X registers. We're going to load X into the 60 right here again, same spot. And this time we're going to load 249 into our counter spot, our loop counter right here. We're going to move count into X just like we did before, and we're going to increment X, so it's the same number, 1. But this time we are going to load count, and instead of adding 1 to count, we're going to shift the digit left 1 bit. So first in binary is 1, and now it's going to move to 10, which is 2 in binary. And then the next time it's going to load to 100, which is 4. 8? Yeah, 4. 4, yeah. And then it's going to do that for the first 7 memory locations, so up to here. So this is represented in hex up here, so it's not going to look like it. It's not going to look like this down here, but we will see exactly what it looks like. So now 2 is going to be stored in our counter, which is going to boom and be put into here. Our loop counter incremented, and then this was stored. So the next time through, this is going to square again, so this is now 4. So 1, 2, so this is x to the 0 power, or 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, which is 16, but this is hex, 2 to the 5th power, 2 to the 6th power. And that's 1, 2, 3, 4, 5, 6, 7 locations. And then it's going to reset. That's it.